Yes, hi. I'm sorry I couldn't be there. I was teaching until 2:30 and then hanging out with my students until a little bit past 3. So I only
Yeah,
wish that it had
doesn't
been a
come
different day
eventually.
and I could actually have shown up there. Um, it's funny you mentioned
But
the use of ChatGPT and our bios. The reason being that recently one of my co-authors of a graphics text I wrote a while ago um, went to ChatGPT and asked basically for a little mini summary of the life history of each of the co-authors. And every single one of them started off perfectly reasonably and right in the middle just started hallucinating crazy stuff. So I think for me or from one of my other co-authors, it decided that I got my PhD at UNC Chapel Hill, for example, which I didn't. I mean, I've been there for conferences, but and just the way in which it will say things with such sureness, right? You know, it's just like a student who says something completely wrong, and you kind of like think that they must know they're wrong, but boy, they sound like they're really convinced. So that stuff really, it can be scary that way. There's a meme that's going around right now. You ask it, you know, what are the prime numbers less than 100? And it goes 2, 3, 5, 7, 11, etc. And then you say, but you left out 57. And then it replies, oh, 2, 3, 5, 7, all the way up to 97 and 57. Now, 57 isn't a prime, um, but you tell it it's a prime, hey, it'll just parrot it right back to you. Um, and there are similar examples. People seem to love to do this with prime numbers, where it'll give you explanations for why a number is prime because it is an even multiple of an odd number, or other things that just are like, what? So I would be very, very careful with anything that purports to be factual that you get out of ChatGPT, let alone that issue of it basically churning out things that were part of its training set. So it's making believe that it created something that was really created by a real person that was not it.
it's a bit like a confident child explaining the world to you. I mean,
Yeah, yeah.
those parents get to the
And
point where they
that's
come up with erratic explanation that ties together, but it's totally wrong.
and that's can be very dangerous when you take it as face value. The same with many people will ask Google a question and they'll assume that the answer that they get back, maybe from Wikipedia, is actually correct. And as we all know, Wikipedia is often not correct, but at least you can go in there and fix it, or you could root it further. So
So
let's see if I can try to get into sharing my screen. So give me a couple of seconds.
I'll give you a quick introduction in the meantime. So
Mhm.
we're just delighted to have Professor Steve Feiner come back to the Media Lab. In this case, he's virtually, but he's an old colleague and friend of many of us here. I remember having the first wearable computing conference here at the Media Lab in 1997, and Steve gave his Turing machine paper there, and we were just amazed. This is the place that had so much to do with wearable computing, that Steve was the first guy to go out there in the real world with augmented reality, image tracking, location-based information, all of that stuff, and show it in a beautiful demo. And the world changed that day. It was one of the ways it changed. So we're just so happy to have him back and have him talk about some of the work he's doing. And if you talk about somebody who has perspective on where this is going, he's got one of the longest perspectives of anybody. So it'd be so great to hear from Steve. We look forward to his talk. Thank you, Steve.
Okay, can everyone see my screen?
Yes.
I want to make sure that I can also see you guys. And there's this horrible thing that Zoom does when you go into screen sharing. It suddenly stops displaying the videos of everyone and basically completely destroys your window setup. I'm trying to see if I can get back the little tiny collection of windows, which is under something over here. Where is it? Come on. Where is the little window that is disappeared? Show video panel. There we go. So the only way I can get this back again is to go to show video panel, click the thing that makes it scalable, enlarge it. If I turned on chat, it would not be docked the way it was before. I mean, this is just an embarrassment. And if there's anyone from Zoom listening, I think they broke it. I believe that right at the beginning of the pandemic, it worked properly. Namely, it didn't destroy your Windows setup when you shared Windows, and it hasn't worked since then. So let me also get chat up, which will be, of course, a separate little non-dockable window, which will then dock properly when everything is over. But at least I can see if anyone is saying anything in chat. So come on, make chat big. Everything has to be hand scaled. Oh, awful. Okay, great. So how much time do I have, guys?
Roughly an hour.
Okay, I'll see if I can fit this in an hour and hopefully have some time left over for questions and maybe even some answers if I can think of them. So I entitled my talk VR and AR in the Metaverse, not exactly a snappy title, but why not? And what I'm going to do basically is I'm assuming, because I've been told that many of the folks in the audience are not even in the class, the VR and AR and Metaverse may be new to them. And so I basically wanted to sort of start with first principles. I, as a researcher, use the term virtual reality and augmented reality in a way that may be different from what people in a variety of industrial places use it. And so I wanted to just make sure they're all on the same page. So my definition of VR, basically, is that it is a computer-generated world of virtual media, that it's 3D, it's interactive, it's tracked relative to the user. And here I have that infamous advertising picture from the release of the very first consumer Oculus Rift in 2016, where lots of money was being spent on searing this image into the brain of anyone who had the slightest interest in VR or was about to acquire that interest. So that's virtual reality. So what's augmented reality? Well, I say it's all of the above, except now our generated world of virtual media is registered, just a fancy way of saying aligned, geometrically aligned in particular, in 3D with a perceptible real world. And one thing I have tried to do with these definitions is I've tried not to be visually chauvinistic. So I didn't say that you see the virtual stuff in conjunction with the real stuff. I tried to use non-loaded words like that. So I said perceptible, not visual, for example. And the reason that I'm trying to use these very non-loaded words is that AR and VR really are for all our senses, even though most of what those of us who do VR and AR do tends to be very vision-centric. Audio really coming along right now, far better than it was not too many years ago, especially for spatialized audio. Touch, not quite as good. You know, the controllers you have in VR, they have little linear resonant actuators in them. They can make a little buzzy thing in your hand. There is some very nice but very expensive commercial work on making things that can really appeal haptically to your sense of touch, your sense of force and torque. But those things tend to be very expensive and very limited in the volumes in which you can do stuff, and very often requiring that you hold things that don't let you hold regular stuff in your hand. And then on top of that, there's taste and smell, which people are actively working on, sometimes in very interesting ways, but which are nowhere near as far along as any of the others are. So really, when I think of VR and AR, I really think of all of our senses, even though most of what people do tend to be limited mostly to vision, hearing, and to some extent to touch. So in terms of visual stuff, even though I've tried to, paint this picture of not wanting to be visually chauvinistic, I'm going to mostly narrow in on visual stuff. And I wanted to mention for people who have not actually used AR or VR devices, essentially the way in which we as researchers like to categorize at a high level, particularly visual AR. So one kind of visual AR, and this is historically the oldest actually, is optical see-through. And the idea is that you have some kind of a display, and optics are used to combine that display, displaying virtual graphics, with your view of the real world. So I can look out onto the real world, I can see stuff, and then in this very simple example of using literally what we call a mirror beam splitter, a little piece of half-silvered glass, for example, I can see through it, I can see a reflection of a more conventional display. So additional optics might be in there to make sure that I can focus on stuff that is displayed, especially if it's displayed really near to me. And now this combination of real and virtual gets done in optics. Many headsets HoloLens, for example, HoloLens 2, Magic Leap are examples of optical see-through displays. Now, another kind is video see-through. So the idea is we have one or more cameras, typically at least two. They look out into the world. They're usually positioned relatively close to where your eyes are. And their virtual content, what the cameras see, is combined together with the virtual graphics in the computer and then presented to you on a display that you look at more or less directly, sometimes with optics between you and it if it's really close. And the great thing about this is that the sky's the limit in terms of what you can do in terms of combining the virtual and the real world that you see through the cameras. Any way in which you would normally do stuff in special effects can be done here. And the only issue is doing it fast enough that things actually happen interactively. And faster computers and better algorithms are making this more and more possible. And the final approach I'm going to mention is projection, in which you have a display that's really one or more projectors. They project out onto the world, and there are surfaces in the world that refract light or that reflect light, and the combination is being done by the actual world surfaces. So I could look into the world in many cases without wearing any kind of special eyewear, and I can see this combination of stuff. I could project advertising 3D stuff on the side of a building, for example, see the real building, and see like a virtual car kind of like racing up the side of the building. So the combination here is now in the actual environment itself. And these three basic approaches you can think of as just talking about the way in which things get combined. You can do a cross product between these and where the different parts of these systems live. So you can think about the display being fully or partially worn, for example, worn on your head, as you might imagine if these projectors and displays and optics were very, very close to your head and attached to your head. They could be held as in smartphone AR, in which you're looking at the screen of your phone. You're looking in part through the camera on the back of the phone. The computer and the phone is combining together the camera view and the graphics that it's generating, and therefore you're now holding your AR display. And then finally, of course, you can, as I said, project into the environment and see real stuff directly combined with virtual stuff. So that is sort of like in as few words as I can use, the many ways in which we combine these things, this cross product between where the different parts of the technology live and the different ways of doing the combination. Now, people have been thinking about this kind of stuff for a really, really long time. Well, how long? This is a quote from a very famous talk, which then got turned into a paper, 1965 paper by Ivan Sutherland. Ivan Sutherland being responsible for basically the very first interactive computer graphics being done at Lincoln Labs. And then in 1965, several years after he got his PhD thesis for doing interactive computer graphics with a nice light pen-based user interface, he gave a talk from which this is a quote, in which he's thinking about what would the ultimate display be. And he says, well, it's not just a visual display. He said it's a room within which the computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in. And then he starts getting very dystopian. Little bit and then a lot. Handcuffs displayed in such a room would be confining. A bullet displayed in such a room would be fatal. And then he lightens it up a little bit, says with appropriate programming, it's always about programming, as you guys, many of you already know, such a display could literally be the wonderland into which Alice walked. This is a wonderful fantasy. 3 years later, as I'll mention, he actually did a little teeny tiny attempt to try to make some of this be true for real. But the interesting thing is that while he's saying this in 1965, a lot of science fiction writers, not computer scientists, have been thinking about this even earlier. And there is actually a very interesting story called The Veldt that is in a collection of stories published by Ray Bradbury, 1951. And that story, The Veldt, which actually is a variant of a story published in this thing called the Saturday Evening Post, I think it was like a year before, is all about a children's playroom that, shall we say, is every bit as dystopian as this the description of the ultimate display that Sutherland is describing over here. So we're talking about a description from 70 odd years ago, right? Of what many of you might think of as being, oh, that's the holodeck, right? You know, which again, also complete total fantasy. But the beginning of something that really is trying to suggest where we might actually want to take this kind of stuff. At least I hope the non-dystopian versions of it. I strongly suggest looking at the story. You can find it online. I'm not sure if it's out of copyright or not, but whether or not it is, there are many sites that will have the full story out there for you to go and enjoy. The Welt, that is. So this is 1965. 3 years later, Sutherland shows up at the Full Joint Computer Conference, 1968. If you did anything with computers, you went to the conference for people who did things with the computers, one in the fall, one in the spring. This is the fall conference, 1968, and he is there not with the actual unit, but with a paper that describes a optical see-through stereoscopic head-worn display that's able to let you see through to the room that you're in, overlay graphics on top of it, move your head around, tracked mechanically. He had an ultrasound tracker and a mechanical one. Only the mechanical one really worked good enough to be able to use. And you could actually move your head around and look at things in the environment. And however, the year's 1968, and you know, he was not exactly, you know, running on a computer with a NVIDIA 4090 in it. He's running on a custom-built machine that is capable heroically of putting up a wireframe cube, like you're seeing over there. And in fact, in the more heroic version, it actually has simple wireframe letters, north, south, east, west, on the sides of the cube. And you can walk around and look at that cube. This was incredibly heroic stuff, 1968. And what I think, to put this in even better perspective, at that conference, same conference, December of 1968, Doug Engelbart gives what my PhD advisor, Andy Van Dam, has referred to as the mother of all demos. He basically is demonstrating a Windows system, multiple windows on a computer, black on white text, which is black and white only because it's really light on dark, and he's aiming an old-fashioned grayscale video camera at it and simply pressing the switch that inverts the video. And he's sitting there with this crazy device that you can see in the left, the mouse. This is the first time that many people at this demo have seen the mouse. And he's got a little cord keyboard and a regular keyboard there as well. And there are multiple people whose video is being sent over many miles of telephone cable between two different sites, collaborating together on editing a document. This was absolutely mind-boggling to the people who saw this back then. And to make it even more mind-boggling, since all of you, of course, use Google Docs and other things that let you share stuff, you're seeing a bit of the screen at the upper left over there, black on white, courtesy of the fact that there's a grayscale camera with inverted video being aimed at it to show it to you. And you'll notice something about the text. You notice it's all uppercase. Well, some of those letters have a little horizontal bar over them. The machine he was using had a hardware generator for the characters. It only did uppercase, and the only way you could actually distinguish upper and lower is you could put a little horizontal bar over the ones that were really supposed to be uppercase, you know, like the initial letters of some of those words over there. And the rest you had to assume were going to be lowercase. So just think about a world in which that was the best you could do with an insanely expensive custom computer. You could have uppercase characters, because computer being used to edit text, that was weird. Computers were for scientific stuff. You didn't edit text with them. 1968. Okay, so, you know, we've been doing VR and AR for over 50 years, over a half century. Although obviously it was not yet the AR and VR, or the VR that any 12-year-old can go and get their parents to buy them a headset for, and then get together with another 12-year-old friend, and suddenly you've got a collaborative system far better than we researchers had just 10 or 15 years ago in stuff running using a Quest now. So what about the metaverse? What is the metaverse? Well, as you all probably know, the metaverse was a term coined by Neil Stephenson. South Crash as a science fiction fantasy, okay? But of course, that name has been popularized by a very large company and a lot of other companies and individuals who are following suit on trying to adopt this word, metaverse, okay? Now, if you got to roll with the punches and do what everybody else is doing and talk about the metaverse, what does it really mean besides being the specific thing that was in Snow Crash? I like to think that what it means to me is basically, in keeping with that attempt to not try to be visually chauvinistic, it means making the imperceptible perceptible. It means making things I can't sense right now. They might not be there, they might be really hard to perceive, but making them easier to perceive, whether I'm doing this by myself or with other people. And we can do it for things that are happening right now, for things that are right now, for what that is. We can unveil content that's occluded because I'm looking at a wall of the building that you're in right now, and I might want to see the actual infrastructure inside the wall. I might want to see what is happening in the room next to you. I might want to see what's happening outside. So there's stuff that I'm prevented from seeing visually or hearing in terms of auditory stuff. And now I want to be able to go and perceive it. It can mean if there's something very subtle, okay, something I don't quite appreciate because I'm not attuned to understanding it well. Maybe I am a novice like me looking at an X-ray, let's say, that would make a lot of sense to a radiologist, but I just don't pay attention to the right stuff. So maybe that stuff can be highlighted. So subtle things can be made to be not so subtle, much easier for me to see. And of course, there may be stuff that simply isn't there, and I can go and display those things that aren't there, those things that I can't hear or see or feel because they're simply not there to hear or see or feel. And now I can add them into my experience of the real world. So let me give you a couple of examples. This is some work that we did a while ago, showed at a demo at SIGGRAPH in 2018. And we basically were taking a commercial model of, in this case, Manhattan, letting you look around. Here we're doing this in VR. We have another user that we're working with whose avatar you can see off in the distance. And now we're taking a bunch of data sets. In this case, it's New York City 311 calls. And we're basically sampling this data set, which is out there, part of New York City open data. And then we're displaying these little placards, one for each one of these calls, into this number that you're supposed to call when there's something that you don't like, but it's not life-threatening. Don't call the police, call 311, complain about the pothole, complain about the noise, etc. And these are all basically complaints, and they're all being positioned above the part of Manhattan that they're associated with. And if I do this live, I can now look around, I can see those. And in addition to those, we also have tweets, which are emanating from the places that the tweet is actually marked with. This, by the way, was a very dangerous demo to give because these were live tweets and we were not filtering them. And anyone who's looked at live tweets knows there's some really nasty stuff out there. And you could really embarrass yourself when someone views a live tweet that might demean some aspect of their persona because of their race or religion or whatever. And sadly, there's a lot of that stuff out there. So here we can look around, see all this stuff. This is all in VR, but in AR, here we're doing it in my lab. We're looking through cameras. This is video see-through AR. There's another physical person off on the side. There's all the normal stuff I have in my lab. And now with AR, we're adding in this view of the city. It's a little hole cut in it so we can see part of the body of this tracked other person. We're seeing, in this case, Yelp reviews and those 311 placards and the tweets I mentioned before. And then off on the side, I've got this basically this kind of bulletin board. And now I can grab hold of one of these placards. I can put it up there. I make a copy of it. And we can just put these things up kind of like Post-it notes. We can arrange them on the board. This is actually being replicated on board the other person sees. And we can do all the standard things I go do with a little note that I might pin on a board or tape up on a board. And we can be talking about it. And maybe we're looking at a complaint about noise, and there's a restaurant review that talks about the live music that they have. And maybe the noise complaint is really near the restaurant. And maybe we can put two and two together and think perhaps this is the reason the noise is there. So you can imagine being able to just vicariously visit different parts of a place and find out all this information that isn't visual information about it when you're maybe thinking about wanting to move to a particular place that you haven't been to before, or you're maybe someone who's tasked with trying to understand what's happening in the city in a variety of ways that might be represented by the kinds of content that you can put up. Here's another example. This is a little bit later, same project where we're trying to have a little bit more sophistication in terms of what we could put up in those boards, making these links indicating geographical relationships between things, being able to stack, for example, all of the Yelp reviews in one place, and the through on one data in another place, and the tweets in another place, et cetera, so we can try to understand what's going on. And build up these hypotheses, which we're sharing with other people that we're interacting with. As another example, and I'll show you just a still image over here. This is work that is funded by DARPA, that my lab is part of a multi-site team that's working on one of a set of teams funded to do what DARPA refers to as perceptually enabled task guidance. And I like to think of this as being basically AI and AR complete. The system is supposed to be able to ingest lots and lots of content, video, maintenance and repair manuals, et cetera, recipe books in the cooking domain, which we're showing over here, on its own, figure out what's happening in all that documentation. And then after figuring out the recipes, how to perform them, the right way to actually do the tasks, the idea is you're wearing a see-through head-worn display, and there is built into the system the ability to, with sensors, view the world around you, figure out what objects are in the world, figure out what activities are taking place in the world, including ones that you are performing yourself, and then give you assistance to, for example, actually follow a recipe and make a meal or make a dish. And so this is one of the first things we worked on, which is frighteningly hard to actually do without really hardwiring it, which is just making simple drip filter coffee. The tasks of grinding the beans, grinding them for the right amount of time, folding the filter into quarters, placing it inside the cone, pouring in just the right amount of water, knowing when to start, when to stop, having the system figure out whether you're doing it right. It's actually very, very hard to do. And this work is joint with colleagues at Kitware, UC Berkeley, UT Austin, and other colleagues at Columbia, with a lot of effort spent just trying to do a simple task like literally pour over coffee. So what about things that happened in the past? So I think that this making the imperceptible perceptible is also really useful for things that were. So presenting in context or instead of what is here now, things that were here before or somewhere before. And because this gets done entirely virtually, I can mix together things from many different times and many different places. And so here is an image, for example, which was made using a nice little smartphone app called Civilizations, AR, from the BBC. They have a variety of lovingly crafted and relatively decimated models of historical stuff. This is a sandstone sculpture of Mars, courtesy of the Romans in the early 300s to 400s. And here I've positioned it standing between two rooms in a hotel suite, basically. It has no reasonable reason to actually be there, except I wanted to make a picture of this sculpture that, is clearly way out of place from where it really was found, just sitting in my hotel room. Another example, same application. This is a Tang Dynasty horse, earthenware funerary object. It's sitting now on a tabletop in another hotel room. And of course, it's purely virtual. And again, these are things you can do with just a plain old smartphone, essentially, to mix together things from different times and different places in the world around you. One more example, this is work that we did nearly 19 years ago. My lab and that of a colleague, Peter Allen, at Columbia, we visited a archaeological dig site in the western part of Sicily, Monte Polizzo. It was a Stanford dig. We basically managed to piggyback on it and took along a really high performance laser scanner. And when the archaeologists on the top of an extraordinarily hot mountain in the middle of a very, very hot summer left around noon, a little bit before, we then took over and scanned the dig site. And what you're seeing over here is basically a reconstruction of that dig site. So you can look around, you're at the top of the mountain, there's the scanner off in the distance over there. And this is what remains of the very interesting structure that was built. Apparently, there were a lot of interesting things done with sacrifices at this particular site. So I can now look around in VR, see it at life size. And right now it's designed to just pretty much give you the experience of being there. And now we can add to this. In this case, we're now seeing overlaid labels and indications of different finds that were found at the site. And now we get rid of the backdrop, and we're actually in my lab doing this, walking around relative to this site and mixing together this thousands of years in the past dig site with a completely different physical place, seeing also the things that are happening in it right now. Now we can also look at what could be, what's going to happen next, and present in context, or instead of what is there right now, future things. It can make future predictions about a building that's going to go up at a particular site. What is it going to look like? What will our city look like, 50 years from now? Maybe I want to completely replace my environment that I can physically experience with some prediction about what it's going to be. And one very exciting thing is that if you actually try to build on a site a prediction of what something was like in the past or what it'll be like in the future, usually many people will try out, especially if it's an architectural competition. One team will win and they get to actually do it, right? And if you're doing it in AR or VR, everyone can get their chance to go and see what they think their future would look like or what the past would look like. So you can have lots and lots of simultaneous predictions of the future, predictions of the past. So to give you an example, a little bit more researchy, one of the things that my lab is working on right now is predictions about and information about tasks that you are going to perform in the very near term. And so we've been looking at so-called cues that will tell you about what you're going to be doing right now, in this case, in a task that involves picking up a set of objects and moving them around and changing their orientation as you move them. These yellow and cyan lines and these little funny green and gray wedges are part of a particular iconography we're using to communicate to someone what to do next. And then the yellow is what to do right now. The cyan lines of various levels of darkness are showing predictions of what you should do next. Where we're trying to see, when we do this, can we get a person to be able to perform better, no more mistakes, but actually a bit faster than if we didn't give them these predictions about the future? Can telling you about something that you're not doing right now, but you're going to do really soon, can it help you do things a bit better? Another example of this on the right over here was if you use Vive and Valve equipment, you'll recognize these things as 6DoF trackers. And here we're showing, making believe that this is actually kind of like a knob, let's say on a control panel. There's a set of little concentric arrows that are showing you a series of rotations that you are to do of this tracker mounted on a pegboard, again, showing you a series of rotations that might, if it were a mixing console, for example, indicate turning things down and up and down and up at a certain in a certain sequence. So to tell you a little bit more about some of this work, one of the things that we've been particularly interested in is what happens when the tasks involve multiple hands. There's a bunch of different things you can do. You're going to decide what it is to do next, and you can do things concurrently. So my left and my right hands can both together do stuff. So bimanual, unordered, any order, concurrent, things can be done at the same time. And in this work, we see one of my students who was part of the team that did this, wearing a very high-end video see-through AR headset that we're actually using in the particular project I'm going to show you purely for VR. This is a Vario XR3. She's holding a pair of controllers, and she's going to use them to actually perform this task. And what we're going to try to find out, and what we've tried to find out, is how does the number of cues that we show you affect performance? You know, you might think more would be better, but if the cues start obscuring each other, you can end up with a spaghetti bowl of cues that might actually make things worse. So can we see how much better things can get and how much worse things can get as we increase the number of cues? And in the work I'm going to explain to you, maybe there's a way in which we can select which cues to show in an adaptive way, and that might make the performance better. So the task that we did over here is a very simple one. We have a bunch of these cylinders that you're seeing. And what's going to happen is we're going to basically be instructed by the colored lines that you're seeing to pick up and move the cylinders, in each case moving a blue cylinder, they're all blue, to the connected destination that's see-through, following a line from that cylinder. And so here you're seeing this happen, and we're picking things up. We can do things in parallel, we can do things sequentially, and we're trying to very quickly, without making mistakes, move those cylinders into their destinations. And if you look at this schematically, we have an environment 1.5 meters wide, around 0.6 meters deep. You're seated in front of this virtual tabletop, and here you're seeing down an example task. There's a collection of these blue projected as circles cylinders, and you're just going to pick them up in whatever order you'd like to, and then move them to their destinations. And so one thing we were looking at with the iconography that I just explained, solid cylinders, a line, a colored line connecting the object and the destination, semi-transparent replica at the destination. And again, as I mentioned, you can actually do two things at the same time. So in this case, you're seeing someone grab hold of two of these things and move them. Now, when they did that, you'll notice additional ones of those lines appeared. And what we were looking at was, if in this case we have a relatively small number of these cylinders, but let's say we had a lot of them. If we had all of the possible lines, again, it would start looking like a spaghetti bowl. It'd be very hard to follow a line visually. And so we're looking at, could we actually put a subset of those cues in there? And again, you're going to get to choose which ones to actually do. And so we looked at, in one of the studies we did, 3 different ways to update our subset. One of them was that statically, we would at any given time have a particular set of these cues available. In this case, I believe we were doing 4 cues, at most 4 cues. And whenever you'd follow one of the cues, another cue would come in there. But you had no control over which cues were coming in. We had another approach using hand proximity. So the cues that came in were based on the cylinders that were closest to your tracked hands. And then we also looked at making the cues that came in be the ones that were closest to the most recently looked at cylinders, because we're tracking your eyes in this work. And so here we have a static cue updating approach. As you move things, each time you move something, new cues appear. And you have no control over which cues appear, however. But you, of course, can pick any 1 or 2 at a time of those cues to follow and to move. Here is hand proximity, where the cues that come in are going to be based on where I put my hands. In this case, track controllers. So as you see, as my hands move around, I control what cues go into the cue set. Here is using eye gaze, and you're going to see a little cyan dot. The dot was not used in our study. It's being used here so you guys can understand what's going on. The person in the study doesn't actually see that eye gaze dot, but the eye gaze dot is going to determine which cues get brought in, and the set of cues will be the 4 cylinders most recently looked at. So we see looking around over there, and intentionally this person is just looking around just to help you understand what's happening with the eye gaze. So let me show you again another sample eye gaze trial. Now, the interesting thing here is that, as you're looking around, unless you're really, really very well disciplined, you may look at something, and as you're getting ready to grab something and you look at another thing, maybe the cue you're going for is going to disappear because it aged out, because it's not one of the 4 most recently looked at things. And you're going to actually see that happening over here. Watch as the person moves their right hand. You can really feel they're getting ready to move one of the cylinders, and they missed it. Notice how that happened at the very beginning over there. So this particular approach, it turns out these approaches were very frustrating, because unless you were very disciplined to, once you had looked at the 4 most recent things, not to look at other stuff while you were doing it, things could basically age out in this very unpleasant kind of way. And so as we were playing with this, we came up with the idea of trying to see if there were things we could do that would lock some of those cues in place. And so here's what we mean by that. So here are 3 new cues that we're seeing. And the next thing we're going to see is the left controller is going to move closer to a cued object. And when that happens, we're using controller proximity to lock that cue in place. Now, what I'm showing you here is the cylinder turning red to indicate its cue being locked in place. We didn't actually do this in the study, but I'm showing you in the visuals I'm showing you right now, things turning red, just to enable you to understand which cues are being locked. So that hand moved in close to that cylinder, its cue gets locked. The other hand gets closer to the cylinder, the one that is now red over there, it's the closest cylinder to it, it cues gets locked. And that means it's going to be locked in there until you actually follow it. So once you get 4 things in there, you can look around anywhere you want to. No new things will get pulled in until you get rid of the ones that were locked in. And then again, and this is eye proximity, then eye proximity gets to take over to add things, but they'll get locked if you get your controller closest to it. And so this is an example of what this looks like. Here I'm showing it to you at half speed so you can really understand it better. This is an actual eye gaze trial with locking. So we're showing the lock cues in red in what I'm showing you, but people who were actually doing this in our study did not see that little cyan dot, and they didn't see things turning red either. So here, as notice, those are now locked in. More are getting locked in over here. I can look around if I want to, with the sureness of knowing that I'm not going to go and make things that are in the set get out of the set, and therefore make me aim for something and suddenly, it's no longer in the set. So there was a study. In the interest of time, I have gotten rid of all the slides that talk about the demographics and the tests that we did, et cetera. Suffice it to say that this notion of locking combined with eye gaze made for a very, very good way of being able to select what cues to show a person, when showing all the cues would have really been overkill and made a kind of spaghetti bowl out of the environment. So at this point, I think I'm getting close to finishing. I want to mention one more thing, and I think it's extremely important. It's something I've been talking about for quite a while, and that is some of the privacy issues of worlds in which people are wearing cameras, wearing mics, which is clearly what is going to happen. Google Glass has this. Snap has a variety of commercial and not quite commercial headsets that have cameras, even just cameras and mics in them from the very beginning. And now in the case of Spectacles 2021, the not quite for sale headset they have, there actually is a display in the headset. It's a stereoscopic optical see-through AR headset with cameras that can capture the environment. So the thing is, what if we're all wearing cameras? We're all wearing mics, right? And we're walking around and our position is known. The exact time at which stuff being recorded is being known. So we have recording, essentially, time-stamped and geotagged snippets of stuff. And there's all of us walking around and doing this. And let's say there is a company that really would like you to log in when you search, and that would love to let you search and already let you search with images, and would love to let you search with full videos, and would love for that full video and full imagery to be stuff that you're capturing even as you walk around, right? And all that stuff is going up there and updating all their databases. And now you've got this really interesting notion, and I think a little bit scary, that if I'm walking around with somebody, maybe having a research conversation, as one of my students, we're talking about something we really prefer our colleagues not know about because we want to write a paper on it. And as we walk around, maybe we're going to be a little careful. And if there are folks who do research like ours and they walk up to us, we're probably going to stop talking about it. But if we walk around and there's no one walking right behind us, there's people passing us every now and then, or maybe not so every now and then, but they're going to be there for only a matter of a second or so. They'll hear at most a word or two, maybe part of a sentence. But if all their stuff is being uploaded, geotagged, date stamped, very accurately geotagged, all of those microphone recordings and video recordings can be combined together to reconstruct an incredible view of our conversation with amazing quality audio and amazing quality video, and the ability to even like walk up and walk along with us if you wanted to and hear the entire conversation. And the thing is, as far as I know, there's really no legal way to stop that. If I'm walking around in public, I don't have any expectation of privacy. You can walk by me and you can take my picture, and you can record me. I mean, you can't maybe stick your camera in my face, but you could certainly walk near me and take my picture. Now, if I'm a very famous and very wealthy personality, I could punch you out or have my people punch you out, and then my lawyers will deal with it. But normal people are not going to do that. So everything you do basically can now be captured. And the more of us who wear these camera systems and microphone systems that are essentially invisible in the Mark Weiser kind of sense of you don't even think about them being there, the more this kind of thing can happen. And that kind of scares me because, I kind of like privacy, and I kind of make assumptions that when I'm walking along, that of course someone could with a telephoto lens be capturing me, but come on, I'm not a famous pop star. People don't do that paparazzi thing with me. And now, because everyone walks by, my grandma could walk by, and there's a little bit and snippet of her stuff that could then be used to reconstruct this conversation, even though she heard only a word or two of it and didn't even care except to say hello. I think it actually gets even worse than this, because there are now headsets that not only track your head in terms of position and orientation relative to the world, they're also tracking your eyes, and including tracking the size of your pupils, which can provide some very interesting information about what's going on. You're tracking your hands, and any of you who have a Quest or Quest 2 know that when you turned on head tracking, you had to basically check off, virtually signing something saying, you do understand that information about the size of your hands, Mr. Trump, can actually be recorded, right? And, we are able to capture that information. You can capture a face, as with a Vive Pro with a facial tracker, as with the HP Reverb G2 Omniset edition, which has a little camera capturing your face, as with a number of consumer things that will be coming out very soon that will be able to capture face and capture eyes, for example. And many of these things, or some of these things, can also capture pulse. For example, the Reverb G2 Omnicept edition has plethysmography, so it can actually capture your pulse. There are headsets coming out right now that have EEG, dry electrode EEG, built into them that can capture things happening in your brain. So with all this stuff, right now, not quite yet as commonplace, although still pretty inexpensive. The facial tracker for a Vive Pro is what, I think $100 and change maybe. We are going to be able to not just filter stuff. When I capture my stuff, right, I could decide not to allow an application to get at it. The same way that right now, if you have a Quest or Quest 2, the cameras nominally used for tracking can be used to reconstruct a kind of cheesy stereoscopic grayscale view of your environment. And yet the application can't actually see the contents of any of those pixels. That's intentionally not available. However, in other headsets over here, that stuff definitely is available. But I could decide, if I control the application, that I'm going to filter that data and not capture it. Okay. And if I make the application available to others, I may make it so that I will not capture their data or not capture it and let it go off of their headset, for example. But another problem is that I'm wearing a bunch of sensors. What if my sensors can also track other people's biometrics? And I don't filter those because they're somebody else's biometrics. There's a lot of people have done work, including folks at MIT, at taking a regular RGB camera, aiming it at someone's face, and then being able to tell their pulse because of the changing amount of red in the color stream that the camera is capturing, which corresponds to your pulse. A high enough resolution camera could capture lots of things: the motion of someone's eyes, reflections from their corneas of things happening in the environment. The smaller the things you can capture, if I'm playing a game with you, I can capture your controllers. And your controllers, if you have some kind of incipient disease that hasn't yet fully manifested itself, might be showing a little bit of a shake that your insurance company might be very interested in finding out you have right now, because it's a good indication of maybe a pre-existing condition, which they would prefer not to insure you for. And you might not even know you have it, but get that tracker data for the controllers, and you might be able to predict these things and know about them. So this, I think, is really scary. Other people can capture stuff about you, and not just the stuff that they would capture hearing you and seeing you in that conversation, but things being tracked by the headset that you're wearing, that nice lightweight future headset that is tracking pulse and tracking EEG and tracking FNIRS and lots of other fun stuff that you'd be able to go and track with something that you wear on your head or that you hold in your hand. So there's a good part of this. Namely, if I'm having a conversation with someone else and I'm moving my hands around in a way, bare hands, and my sensors on my head don't see it, your sensors see it, you share your sensor data with me, I share my sensor data with me, and now we benefit from each other's sensor suites in two different locations. That's a wonderful way to interact with another person. But on the other hand, maybe the people I'm passing in the street that I don't want to interact with, that I don't want to share with, they can just capture this stuff because their sensors sense the things that I'm doing. I think that's kind of scary. And I don't know of any way around that, because it seems to me that at least with current laws in the US, I really can't be expecting that I have that privacy that prevents me from being captured by the various sensors that you have, that you wear on your person. So with that somewhat dystopian thought, which I'm happy to talk about later, I would like to acknowledge the many funding agencies and the many colleagues, students, and other colleagues that have participated in the work that I've talked about. And I hope I have enough time to be able to answer some questions. Thank you.
Turn around here. I think we definitely have time for questions. So does anybody in the physical world have questions? It's intriguing that both talks have so much promise, such a new world coming that we can kind of see, but there's always a dystopian note. But yeah, we have to be careful because there are new capabilities that come, and all players are not equal in this landscape. So it's a complicated world, and we got to do it right. But that said, open the floor. How about the virtual world?
There is one question.
Okay. Do you want to, Danny, do you want to grab the mic and read it, or should we just look at your text?
Here.
I think we
Oh, it was.
Go ahead. Go ahead.
Are you able to hear me?
Yes.
Yeah.
Just a quick question. When you were on the cues,
Yes.
I was wondering about the system 1 cognition versus system 2, where you know, a task that would be very easy to do because you don't have to think much about it. But introducing cues where now you would think the cues would be helpful, but you're forcing your mind to now have to think about something, in which case those cues in and of the existence of the cues in and of themselves kind of slow you down, even though they might be helpful information. And how do you
Right.
explore the result of that?
Yeah, I think that's definitely interesting. That's one thing that we were able to see, especially with rotational cues. And although I didn't show it, I showed actually a still image of it towards the beginning of my discussion of cues and pre-cues. In that scenario in which you are basically being shown this set of lines that connect things together with the AR example of those Vive trackers that you could pick up, and you had to move them to a destination position and a destination orientation. It turns out the rotation cues, for most people, they don't help, okay? They're just clutter. People don't take advantage of them, okay? Now, on the other hand, the PhD student, Jen Schroeder, whose work that is, and who's done that quite a lot, he actually benefits from multiple rotational cues in the future, okay? And he can benefit from more cues in the future. And so I think of this as being a little bit like, you know, our experience in day-to-day life. There's lots of pre-cueing that go on in regular, normal physical environments. If you think about something as simple as Western musical notation, you don't just look at the note you're playing right now. There's the rest of the measure. There's the rest of the line. There's the rest of the page. If you have enough of a desk to spread things out on, there are many pages off into the future, and you can look to see ahead, right, what's going to happen, to take into account what you should be doing right now to make it sanely merge into things that are happening very, very soon or happening not so soon. Okay, so we take advantage of that. If you read aloud a story, let's say to a little kid, and there are different characters, and a sentence starts with a quote, right? You should probably be reading to the end of the sentence where it says, said the dragon or said the prince or whatever, so you read it in the right voice, right? So we're looking ahead basically to take things into account. In computers, think of Dance Dance Revolution, where even in 2D, cues roll in from the bottom. Beat Saber, there are things coming at you from a distance. Now, the interesting thing about DDR and Beat Saber is the Dance Dance Revolution cues, they don't overlap each other. They're kind of like music notation. They're spread out in 2D and they scroll up in this case, okay? In Beat Saber, the sooner cues, the cues for the next things you have to slice or avoid, they are blocking the ones that are behind it because they're coming to you in a column, basically. In some of the stuff I showed you, the tasks are more 3D spatial. This thing goes here, and then that thing goes over there, and then this thing goes over here. And so the cues actually can block each other. And so taking into account whether that kind of blockage is going to take place, whether you literally have a spaghetti bowl where trying to follow one strand from one place to another is going to be really hard. If there was a single strand of spaghetti, pretty easy, right? With just a couple of strands of spaghetti, it's already a problem, right? So I think that you're right. There are definitely cases in which you can have, and without even very many cues, too much stuff there, too much confusing things that are going to make your performance be less good, not better. But especially if you're able to train, you can get really good at seeing those cues about what to happen, what's going to happen, what needs to get done in the future. And so I think we've never actually done a study yet in which we do multiple sessions during which we really try to get people up to speed of being able to use more of the pre-cues, except anecdotally insofar as the students who've actually were part of the team doing this in our lab have gotten to be better with more cues than people who have not had that training.
That's really interesting. Thank you.
Yeah, it's interesting, Steve, that you talk about pre-cues. I'm kind of intrigued with the future of augmented reality that's precognitive, right? In the sense that a lot of it, you have labels and texts and things that you see, but in some sense, you start doing things before you even realize that you have to do it. You're starting to look at that now with eye tracking and other things engaged. Do you think this is a future of it, is a promising future where you augment in a really natural way, maybe plasticize over time, but it's precognitive. It's not just always hearing the voice or seeing the text.
All right. I think certainly there are things that you pay attention to in a much more, well, visceral is not the right word, but the meaning is in a way that doesn't necessarily involve real serious cognitive processing. For example, there's some very nice work that Ronald Bailey and McNamara, and I'm forgetting the rest of the co-authors did, which was published at SIGGRAPH on this notion of subtle cueing, where the cues were given in the periphery. You're very sensitive in your peripheral vision to rapid changes. And you can even tell this right now. If you put your arms out literally 180 degrees, you probably won't see your hands if you look straight ahead. But if you start wiggling your fingers, or even better, have somebody else put their hands there whose fingers you can't control, you'll actually see them even when you're looking straight ahead. No motion of the neck, no motion of the head, eyes looking straight ahead. You can actually, it's one way you're proving to yourself that you have over 180, typically around 190 degrees worth of horizontal field of view with one eye, both eyes, or the other eye, even when you're looking straight ahead. So in their work, they basically made this little very rapid fire thing happen off in the periphery. And the idea is when that happens, you're instructed, look at it, right? And by the time you look at it, they stopped it. But the idea is to get you to look somewhere. So you can imagine a system that might be making some guesses about something interesting that you should really find out about. And it just calls your attention to a place. And now you have to process what's happening over there and figure out if is it dangerous? Is it interesting? And pick your favorite domain, and you can have all kinds of versions of interesting for things that you're now classifying by having your attention called to it and looking at it. So I think that kind of stuff, the ability to, as our displays get better and better, to present subtle audio, subtle visuals that help me understand things better, that highlight very subtly, maybe a little bit like highlighting with a highlight marker, important parts of something I'm reading, for example, or something that I'm looking at. Call my attention to things that are of interest. Add little bits of extra stuff. You see some of this, in many games where there are things you need to collect. Maybe there's a doormat and there's supposed to be a key under it, and there's so many things in theory you could interact with, and the game really wants you to know about this thing. So maybe there'll be a little halo about the doormat, which means, hey, there's probably a key under it. So you go over and you lift it up and find it. right? So doing that with stuff in the real world where you're calling people's attention in a very gentle way to stuff, rather than hitting them over the head with lots of really brash, bright, loud, visually loud in terms of audio graphics. I think that's really where a lot of stuff is headed. Of course, right now, because people are trying to grab your attention, a lot of what we see in AR and VR is very dramatic. It's designed to really grab your attention in perhaps a somewhat unpleasant way.
That leads to maybe one last question. Sorry for talking, I'll ask one last one, and if there's not on the audience, maybe we can do that too. But Dan Gager is here in the back, who's a friend for some years from Bose, but he's the guy that developed over-the-ear speakers that Bose came on for
Yes,
AR.
yes.
And my group has been doing audio AR a little bit with our Kid Marsh project. So I'm interested in your views. You kind of hit on it a little bit, but the whole future of audio and AR hasn't been deeply explored. We think it's going to be very rich. How do you feel about that?
I think it is definitely going to be very rich, and we are already seeing now with things like resonance, for example, in Unity, the ability to do specialized audio, which is incredibly important. I mean, there are things that I can't see because even with my wide human field of view and even with a display that fully covered it, right, vertically and horizontally, there's still around half the world that's behind me that I can't see at all except through reflections, right? And, caustics and stuff beaming into what I can see, and being able to hear things behind me, above me, below me, right? Whether they're real stuff happening, whether it's virtual stuff happening. I mean, that's, I think, really important. And the nice thing is that anything that lives on your head that can present stuff to you visually, as Bose clearly knows, can also present audio to you. And if you can track the head, you can make that audio sound like it's coming from a particular place. So, I was very saddened to see when that product, stopped being a product. But I really think that since audio has gotten so good, back in the early days, audio on headsets was not very good. But people are willing to pay a lot of money for things that sound good. And that means that a lot of companies are trying to capture the folks who are trying to pay a lot of money and make them not have to pay a lot of money. And, it's a wonderful competitive world. And given how important what we see and what we hear is, and the increasing ability to make sounds that sound like they're coming from a particular place, that sound like they're coming from a particular environment because they are bouncing off of and being absorbed by the various surfaces in that environment, that's something we do better and better. I remember a long time ago being very jealous of this device called the Convolvatron that was developed by Crystal River for NASA back in the 90s, costing an insane amount of money worth of these custom DSP chips. And I remember getting a thing called a Beachtron, which was a Turtle Beach sound card. I'm trying to remember when I got this thing. It cost a couple of $1,000s. It could kind of do cheesy head-related transfer functions. And sadly, I couldn't find a single student who actually wanted to do the low-hanging fruit of maybe having, a virtual agent say, hey, over here, this is where you need to screw in the whatever into the something else in doing a maintenance and repair task. And now you can do really pretty reasonable head-related transfer functions that spatialize audio on a regular computer running in Unity. And that's really cool. So I think we're going to see a lot of that, creating these amazing experiences of virtual concerts, capturing the sound, the audio, and as well also the visuals. So you might be able to get up on stage with your favorite performer and, walk amongst the members of the band as they're playing, for example. That's just a really cool concept. And people have been talking about that and showing that. Scott Foster of Crystal River, I remember doing a demo, possibly at SIGGRAPH, purely audio demo, where you got to walk around amongst the musicians playing. You couldn't see anything. You could hear stuff. You could put your ear right inside where the hi-hat was, or move closer to one of the other musicians and literally feel like you were wandering around, at least in terms of audio, on the stage. So I think being able to go to concerts like that, is going to be part of the future.
I remember that demo, and maybe the young people here won't have tinnitus as they get older. Like some people do, going to too many of those loud concerts. I still love them though. We got to transition, but is there any burning question from the audience for Steve before we sign off? It's quiet. So I think maybe we'll thank you, Steve, very much. Great to see you virtually. Hope to see you next time again.
Great to see you again. And I get again my paranoia about this whole dystopian thing, right? I wish that someone would tell me, oh, there's a way to fix that, right? And I don't know a way to fix that, especially when the sensors are on somebody else's body. And, are you going to stop them from wearing those sensors, right? So please think about that and think about maybe there's a way to fix this. And I'd be very happy to find out if there is.
It's a challenge, maybe for a project to the audience. So one for sure. Yeah. Thank you so much, Steve.
Thank you very much. It's great to be there, if only virtually.
Great to see you.
Okay,
bye-bye.
Great to see you too. Take care. Bye.
Okay. This is mind-boggling. From the real pioneer in this whole area, Steve is one of the guys who really started all of this. As I mentioned, the first person to take the step out to show people what AR was like in the wild and what it really could do. Avi's visions. I mean, he's been so many places, but the vision in that talk was it just kept coming. Usually they're a couple, it just kept coming. So it was just so wonderful. True Media Lab style. Anyway, thanks everybody. I think what we do now, I guess this is any announcement for the whole general audience world. We retreat to the class for recitation.
Maybe we could